Example number 5 is for lead compensator, where we need to design 3 lead compensators for the system in this figure that will reduce the settling time by a factor of 2. So this is the design requirement, that we need to reduce the settling time TS by a factor of 2 while maintaining 30% overshoot. So uncompensated and compensated system will have the same damping ratio. Compare the system characteristics between the 3 designs. So let's say given in the question gain K 63.21. So from the open loop transfer function of the uncompensated system, we determine the closed loop transfer function. So this is the closed loop transfer function. Using the denominator of the closed loop transfer function, we determine the closed loop pole. So we have this complex conjugate poles, where this is actually its uncompensated dominant poles, and also we have the third pole negative 7.99. So usually we choose the top left conjugate pole, which has the positive imaginary coordinate. So we choose this one as uncompensated dominant pole, negative 1.007 plus J 2.627. This is actually equal to negative sigma D plus J omega D. So from the value of 30% overshoot given in the question, we can determine the damping ratio using this formula. So the damping ratio is 0.358. Based on the damping ratio value, we can determine theta dP using this formula at cos damping ratio, which is equal to 69.02 degree. Please write your symbol degree. And using the closed loop dominant poles, we can determine the uncompensated settling time. Which is using this formula, and this is the real part of the uncompensated dominant pole. So we have 3.972 seconds. Based on the design requirement, we need to reduce the settling time by a reduction of 2. So the new settling time is equal to the old settling time divided by 2. So this is our new settling time, which is equal to 4 over new sigma D. From this value of new settling time, we can determine the new sigma D, which is equal to 2.014. And based on this figure, we can determine the new omega D for the compensated system based on the new settling time, since we have the value of sigma D new and also theta dP. So we'll be using this formula. Our new sigma D is 5.252. Now we can construct our compensated dominant pole based on new sigma D and new omega D, which is equal to negative sigma D new 2.014 plus J omega D 5.252. So this is the settling time from the uncompensated system. This is the real part of the uncompensated dominant pole. So this is our old settling time. Based on the design requirement, we need to reduce the settling time by reduction of 2. So this is our new settling time. From the new settling time, we determine our sigma D new and also omega D new based on this equation. So this is our new dominant pole, negative 2.014 plus J 5.252, and the open loop poles 0, negative 4 and negative 6. And this is the uncompensated dominant pole.